Welcome to clickmyproject.com. The title of the paper is Using Rule Ontology in Repeated Rule Acquisition from Similar Websites. It comes under the domain data mining. The World Wide Web is a source of vast knowledge including data, information, concepts, laws and rules. Therefore, several studies on the semantic web have been conducted for acquiring and utilizing knowledge on the web. However, most of the information in these studies is limited to factual and terminological knowledge in the form of ontology, while inferential rules are acquired in various domains such as rule-based systems and intelligent agents. As a result, rule markup language have been developed to overcome the expressive limitations of current ontology languages. Rule markup language does not handle the issue of rule acquisition from web pages, and rule acquisition is still a bottleneck in the deployment of rule-based systems. Thus, the development of a rule acquisition method from web pages is required to utilize the vast knowledge on the web. This is an example of rule acquisition procedure. This is the text in a web page explaining the written policies of bn.com, which is one of the representative online bookstores. This part shows acquired rules from the text. Suppose that we have to acquire rules from several sites of the same domain. The sites have similar web pages explaining similar rules from each other. A comparison shopping portal can be an example. A comparison of simple data such as book prices does not need rules, but delivery cost calculation with various options and applying free shipping rules and written policies needs rules. Therefore, the portal should acquire rules about delivery options, shipping rules and written policies from shopping malls if it want to provide an intelligent service comparing more than just prices. In this case, the portal should repeatedly acquire similar rules from multiple malls, and the rules are very similar to each other in terms of their shape and content. For example, we consider two websites, Amazon.com and bn.com, that we are going to acquire rules from bn.com. After we have acquired rules from Amazon.com, we might be able to use the terms and the structures of the rules from Amazon in order to acquire rules from bn. By using the information about rules, we can develop an automatic rule acquisition procedure which decreases the burden on the knowledge engineer. In our proposed work, to decrease the burden on the knowledge engineer, we present an automatic rule acquisition procedure by using the information about rules. However, there are three assumptions in our approach. First one is the rule across different sites should be similar. The second one is that the web page should include practical and executable rules. The final assumption is that the target application requires rule-based reasoning. As we repeat the rule acquisition process across several sites, we can accumulate rules. However, as the size of rule base increases, it becomes hard to reuse rules. Therefore, we used an ontology named rule2onto, which represents the information about rules including terms, rule component types and rule structures. In order to automatically acquire rules through ontology, we divided the rule acquisition procedure into two main steps in order to apply proper methods to each step. In the rule component identification step, we identify variables and values by using an ontology that describes frequently used variables and values in other rule bases. The goal of rule component identification is to elicit variables and values by comparing parsed words of the given text with the variables and values of rule2onto. Even though the patterns and contents of rules of different sites are similar, they usually use different terms that have the same meaning. They use synonyms in most cases, but they sometimes use semantically similar concepts with different rule structures. So we use both synonyms and semantic similarity between identified variables. Subsequently, we compose rules from the identified rule components by using the rule structure of the ontology. The ontology helps to recommend feasible rules with variables. This is the flow of our proposed work. First, select the input rule web page from particular website. Then acquire the rules from input web page. Then extract and display the web page rule. Then get source from the rule web page and identify values and variables. After the acquired the rules, we construct the ontology based on identified variables and values. The next step is get another similar web page related to the input web page. By using this ontology information, we can identify rule components in a new input site. The next step is the component identification. The basic algorithm of identification is based on text matching between rule ontology and the text on a web page. Moreover, we can use information about omitted variables and the relations between the variables and values described in the ontology. We expanded rule to onto by adding synonyms of each term using WordNet. Identified components are denoted in the format of variable instance with variable abbreviations and numbers. The next step is the rule composition. The objective of rule composition is to combine identified variable instance into rules. There are several possible variable instance for one variable on a web page. The first step of the rule composition is the preparation step, where we find appropriate rule from rule to onto. This is done by comparing the identified variable instance with the variables of the rules in rule to onto. The number of all instances of each variable count is calculated. The objective of rule ordering is to decrease the complexity of making rules with identified variable instance. Therefore, we calculate the number of possible combinations of assigning variables for each rule. Next one is the evaluation function. The distance among a set of instances in a text can be calculated with a variance of instance positions. A low value of variance means that the instances are gathered around one place in the text. That is, the variable instance with the lower variance is more suitable for rule instance. We evaluate the distance between the variable instance and the already assigned instance to rule instance. The best first search algorithm is used to the evaluation function. The initialization step includes choosing candidates rules, rule ordering and variable ordering. The final step is the rule refinement. Once the rules are determined, the next step is to complete the rules by assigning variables and value pairs to if or then. The identified rule instance can be converted to the variable value pairs by matching variables and values with identified values and the ontology. Assigning the pairs to if or then is very simple. If the variable belongs to on if part in the rule instance of rule to onto, we assign the pair to the if part of the rule. Otherwise, if it belongs to the then part, we assign it to the then part. The rules automatically generated are not complete in most cases, so we need to refine them. Next, we see the demo of our process. First, load our project into NetBeans. Then add all jar files into libraries. Just right click that first Java and click Run File. Select the domain. First select book, then select input rule web page. This is the rule content. This is the rules from the page content. Next click ontology file. Okay. We generate the ontology used in rule to onto procedure and also identify the components. Then next click the identification. Select another text web page. Click view web. This is the input content from the text web page. Then click extract text. Then click component identification. First click the synonym set. We compute a synonym of each identified component. Click Component Identification. This is the rule components of new web page. Then click Rule Composition. First click Variable Instance. Totally, this is the rule variable instance. Then next one is rule instance. Totally we have 3 rules. Then calculate the instance count. Next one is ordering. This is the rule ordering and also the variable ordering. Then next click the rule compose button. These are the rules. Totally we have 3 rules. Final step is the rule refinement. This is the final rules. Thanks for listening.